Chapter 18.2 The Sign Test. Many government statistics, such as weekly income and housing prices, are published using the median due to the prevalence of outlier in this data. However, as you have learned, there is no corresponding parametric procedure to test for median. That is where a sign test comes in handy. The sign test is very versatile non-parametric procedure that can be used to estimate a population median or if consumer prefer one product to another. Each observation from the sample is assigned a plus sign or a minus sign. The test statistic is simply the number of plus or minus sign from the sample. Using a one-tailed sign test for the median, small sample case. For the sign test, I'll first address the small sample case where n less than or equal to 20. To demonstrate this sign test, I will revert back to the statistic and practice example at the beginning of this chapter. Suppose United Medical wanted to see if the number of steps walked per day by its population of employees is less than 6,000. Using the Fitbit device, the data shown in Table 18.2 were collected from a random sample of 9 employees. This data can also be found in the Excel file dailysteps.xlsx. The following step will show you how to test this hypothesis using the sign test when alpha equal to 0.1. Step 1. Identify the null and alternative hypothesis. Because United Medical is interested in knowing if the population median is less than 6,000 steps per day, I will assign this statement to the alternative hypothesis. Null hypothesis is median greater or equal to 6,000 steps per day. Alternative hypothesis median less than 6,000 steps per day. Step 2. Count the plus and minus sign. This step is easy. Simply assign a plus sign to any data value above the hypothesized median or 6,000 and a negative sign to any data value below the median, as table 18.3 shows. If any value happen to fall exactly on the median, remove it from the sample. For this example, we have 2 plus sign and 7 minus sign. Step T. Determine the test statistic or S. The test statistic for the one-tailed test S is the number of plus sign or minus sign depending on the alternative hypothesis. Because our goal is to prove that the median is less than 6,000 steps per day, the test statistic is the number of minus sign, which is S equal to 7. Notice that the original data, number of steps taken per day, is at the ratio level of measurement. When we convert the sample data to the number of plus and minus sign, we have reduced the level of data measurement to ordinal where there is no meaningful difference between the data value. Remember, parametric procedures don't work with ordinal data, but non-parametric procedures can. Step 4. Determine the sample size or n. The sample size is the total number of plus signs and minus sign. For this example, n is equal to 7 plus 2 equal to 9. Notice that the data value 6,000 is excluded from the sample size because it falls exactly on the hypothesized median. Step 5. Determine the p-value. If the null hypothesis is true, which we assume unless proven outside, otherwise, the probability that an observation drawn from the population of United Medical employees is assigned a plus sign above the median of 6,000, equal to 0.5. The same can be said for the probability that the observation is assigned a minus sign, because each of the 9 observations from our sample must be assigned a plus or minus sign. This sampling distribution can be said to follow the binomial probability distribution with p equal to 0.5, where p represents the probability of an observation being below the median of 6,000. The binomial distribution was first introduced in Chapter 5 of this textbook. Table 18.4 shows the binomial probabilities for all possible value of x, or the number of minus sign, when p equal to 0.5 and n equal to 9. The probabilities can also be found in Table 1 in Appendix A, which can be found in the print version of the textbook. Figure 18.1 shows this binomial distribution graphically. Table 18.4 shows the binomial probabilities for all possible value of x, the number of minus sign, when p equal to 0.5 and n equal to 9. The probabilities can also be found in Table 1 in Appendix A, which can be found in print version of the textbook. Figure 18.1 shows this binomial distribution graphically. In our sample of 9 observations, 7 were below the hypothesized median of 6,000 steps per day. The p-value for this hypothesis test represents the probability of observing 7 or more observations below the median if the null hypothesis is true. The p-value for the small sample 1 t-test is found using equation 18.1. For our United Medical example s equal to 7, using the probabilities from Table 18.4 or Figure 18.1, the value equal to p-value equal to p x greater or equal to 7 equal to 0.0703 plus 0.0176 plus 0.0020 equal to 0.0899. Step 6. State your conclusion. Table 18.5 shows the decision rule for hypothesis test using p-value. Because our p-value 0.0899 is less than alpha equal to 0.1, United Medical can reject the null hypothesis and conclude that the median number of steps walked per day by the population of employees is less than 6,000. An upper tail hypothesis test, one in which alternative hypothesis median greater than 6,000, would follow the exact same procedure as the lower tail test, with one exception. The test statistic S would be the number of observations above the hypothesized median. Using a two-tailed test sign test for median with small sample size, we will now examine the two-tailed test with a small sample size and less than or equal to 20. Suppose a consumer research group would like to test the hypothesis that the median number of text messages sent per month by a Verizon cell phone customer equal to 700. Table 18.6 shows the number of text messages sent by a random sample of 11 Verizon customers. This data can also be found in the Excel file median text messages.xlsx. The following step will show you how to test this hypothesis using the sign test when alpha equal to 0.05. Step 1. Identify the null and alternative hypothesis. This is a two-tailed test because the consumer group is interested in testing if the median number of test messages equal to 700 per month. So, null hypothesis, median equal to 700 texts per month. Alternative hypothesis, median not equal to 700 texts per month. Step 2. Count the plus and the minus sign. Table 18.7 shows we again assign plus and minus sign to the values above and below the hypothesized median of 700. For this example, we have 8 plus signs and 3 minus signs. Step 3. Determine the test statistic S. The test statistic for the two-tailed test sign S is the larger number of the plus sign versus the minus sign. Because we have 8 plus sign and 3 minus sign, we set S equal to 8. Step 4. Determine the sample size N. The sample size is still the total number of plus signs and minus sign. For this example, N equal to 8 plus 3 equal to 11. Step 5. Determine the p-value. The p-value is still found using the binomial probabilities for p equal to 0.5 and n equal to 11. The probabilities are shown in table 18.8 and their distribution is displayed in figure 18.2. As equation 18.2 shows, the p-value for a two-tailed sign test is the probability of observing S or more observation away from the median time a factor of 2. For our test messages example, S equal to 8, using the probabilities from table 18.8 or figure 18.2, the p-value equal to 2 times p of x greater or equal to x. P-value equal to 2 times 0.0005 plus 0.0054 plus 0.0269 plus 0.0806 equal to 2 times 0.1134 equal to 0.2268. Step 6. State your conclusion. Because our p-value or 0.2268 is more than alpha equal to 0.05, the consumer group failed to reject the null hypothesis. The firm does not have enough evidence to conclude that the median number of text messages sent per month by Verizon customer is not equal to 700. Using the sign test for the median large sample size. With a sample size of n equal to 20, greater than 20, the sampling distribution for the sign test, assuming the null hypothesis is true, p equal to 0.5, if a normal probability distribution. This is because the normal distribution can be used to approximate the binomial distribution when working with a larger sample size. The mean and standard deviation for this sampling distribution can be found in equation 18.3 and 18.4, where m is the mean of sampling distribution, s is the standard deviation of the sampling distribution, n is the sample size. The test statistic for the sign test with n greater than 20 is shown in equation 18.5, where Zs is the test statistic for the sign test, S is the number of plus or minus sign from the sample, M the mean of the sampling distribution, lower s is the standard deviation of the sampling distribution. We will demonstrate this sign test using the following example. According to Dida.com, the median order size of clothing purchased on the internet in 2012 was $114. Suppose we would like to see if the median order size for the population has increased since then. We will use a random sample of 53 customers who represent purchase clothing from a website. Table 18.9 shows the data for the sample. Let's take the following step to test this hypothesis using the large sample sign test when alpha equal to 0.05. Step 1. Identify the null and alternative hypothesis. This is a one-tail test because we are investigating if the median order size has increased over the previously reported value of $114. Null hypothesis: median less than or equal to $114. Alternative hypothesis: median greater than $114. Step 2. Determine the value for S. For this sample, we have 34 plus sign and 17 minus sign, as the table 18.9 shows. Because we have an upper tail test S equal to 34, which equals the number of plus sign in the sample. Step 3. Determine the sample size n. The sample size is still the total number of plus signs and minus sign. For this example, n equal to 34 plus 17 equal to 51. Step 4. Determine the test statistic Zs. Before calculating the test statistic, we need to determine the mean and standard deviation of the sampling distribution using equation 18.3 and 18.4. Step 5. Determine the p-value. We can use equation 18.6 to calculate the p-value for this large sample one-tail sign test. Using equation 18.6, the p-value is p for x greater or equal to Zs. P-value is equal to p x greater or equal to 2.24 equal to 1 minus 0.9875 equal to 0.0125. Step 6. State your conclusion. Because our p-value 0.0125 is less than alpha 0.05, we can reject the null hypothesis. As a result, we can conclude that the median order size for clothing purchased on the internet exceeds $114. In performing a two-tail sign test with a large sample, the p-value for the test can be found using equation 18.7. Remember, that the value for S will be the larger of the number of plus and minus sign, just as it was for the small sample case. Using the sign test to determine preferences. In addition to testing the median of a population, the sign test can be applied to testing if consumers prefer one product or service to another. In this application, the data values are the brand names consumers prefer when faced with two choices. Because the data or brand names are merely labeled, the level of measurement is nominal. Therefore, the non-parametric sign test is the perfect procedure for this application. I'm sure you can imagine that this type of test would be very useful for marketing product and services. We will demonstrate this technique using the small sample case and then let you try the larger sample case in the next year-turn problem. As a long-time lover of Cheez-It cracker, I find myself offended when somebody claims that Cheez Nip, a competing product, are just as good. To put an end to this silly argument, I asked 14 unbiased individuals to test each product and state their preferences. Table 18.10 shows the result. Because we hope to prove that the population is general prefer Cheez-It, a one-tailed test, I assign a plus sign to the people who choose Cheez-It in the test. I assign the people who choose Cheez Nip and have noticed a minus sign. Person number 8 has no preference and was not assigned a sign. The following step will show you how to test this hypothesis using the sign test when alpha equal to 0.05. Step 1. Identify the null and alternative hypothesis. If P equals the proportion of people in the population who prefer Cheez-It, then the alternative hypothesis support P greater than 0.05. This results in the following one-tailed test. Null hypothesis P less than or equal to 0.05 and alternative hypothesis P greater than 0.05. Step 2. Count the plus and minus signs. Table 18.10 indicates that we have 11 plus signs and 2 minus signs. Step 3. Determine the test statistic S. Because we are attempting to prove that the preferred brand is Cheez-It, those choosing Cheez-It were assigned a plus sign, so S equal to 11. Step 4. Determine the sample size N. The sample size is the total number of plus sign and minus sign. For this example, N equal to 11 plus 2 equal to 13. Step 5, determine the p-value. The p-value found using the binomial probabilities for p equal to 0.5 and n equal to 13. Table 18.11 shows those probabilities. Using equation 18.1 from earlier in the chapter, we have p-value or px greater or equal to s equal to 0.0095 plus 0.0016 plus 0.0001 equal to 0.0112. Step 6. State your conclusion. Because the p-value 0.0112 is less than alpha equal to 0.05, we reject the null hypothesis. We can confidently conclude that people prefer Cheez-It to Cheez Nips. Thank you.